So I guess before we get started, let's start about counting. Let's literally just get right into counting. So if you put your, you get your fingers out and you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Simple, right? Grade 1 math. Someone write in the chat though, what do you notice very different about one of these things that I have on the screen? So something's a little different than the rest of them. So if we were to play like which one of these don't belong, what would it be and why? So if you look, someone just type in the chat. I got the chat up. One hand is lower. Yeah, absolutely. I'm more looking at the numbers above the fingers. Yes, Dean says 10. Tamara, 10. Yes. 10 is 2 digits. Now, you probably take these things for granted every day. I know I sure did. But if you think about it, what 10 actually means, 10 doesn't mean what I don't think it, with kids, we just think it's just the next number in the sequence. But 10 actually has some very important meaning. And you see this, that the 1 in the 10 spot represents a full set of hands. These are all my fingers. Don't know if you knew that, but that's actually why we have base 10. There's been Arabic, and I'll try to do this, where they actually would do base 12. And they would do base 12 with 1 hand, 4 fingers. Check it out. Here's how they would count. They would go 1, and see, you see each of your fingers has 3 segments. So here's how they would count. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then actually they would come up with 2 new words, really, A, B, and then this is their 10. Because that would mean a full set of things. Thank God we did not do base 12. It would be a lot of difference and probably difficult. But for the next, let's go 20 minutes or so, you and I and everyone in this room are going to go on a little trip to Mars, okay? So everyone, right now, we are all Martians. I am your K to 9 math teacher, and those are your fingers now. These are your fingers. You do not have those other digits. You only have 3 on each hand. So I can't see you, so I'm assuming you're doing this, or I'm just looking weird. But if you could pick up 3 fingers each, now what I want you to do is let's count these. So I would count 1. Now I know you're muted, but I have been in many elementary classes, and kids, join in. So join in. I know it's weird. I can't hear you, but let's do it anyways. Count with me. 1, 2, 3, 4, 5, 10. If you said 6, that's okay. That's okay. 6 is no longer allowed on our planet because this is actually 10. This last kind of finger, what that means is again, it's 10. It's not 10 in a sense that those humanoids, those weird people on Earth would think it is. It's 10 because it's a full set of fingers. This is a 10 to me. Why? Because these are all the fingers I have. So if I had 10, and if Chris was to show up 10, if Chris could put 10 up in his thing, so we would count by 10s. You are now looking at a Martian's world of 20 fingers. 10 for me, 10 for Chris, 10 plus 10 is 20. All right, hopefully you're a little confused because now we're gonna fly through grade 1 to about grade 9 in about 20 minutes, little Martians, okay? I will go slow, I will speak in humanoid, but we are Martians, okay? So let's think about this. What I want you to do is type in the chat box, what number do you see there? We are in Martian world. Type in the chat, what number do you see? Remember, we're only allowed to use the digits 0, 1, 2, 3, 4, and 5. Only allowed the digits 0 to 5, okay? Awesome, awesome. So I see a lot of people shooting 13. Hopefully that makes sense. You got a full set of fingers here. So this would be 10. And of course we learn on grade 1, we're gonna learn how to count on. So we would say 10, 11, 12, 13. Awesome, awesome. You guys rock, you guys are rock. Awesome Martians. Okay, all right, let's do some skip counting. Skip counting, grade 1, skip counting. Come to the carpet, come to the carpet. All right, let's skip count by 3s. Are you ready? Are you ready? 3, 10, 13, 20, 23. What? Okay, so hopefully this is a little confusing, right? Just like grade 1s who are confusing at counting, right? We're going slow, Martians. Okay, so what if we were to skip count by 2s? How would we do this? How would we do this? So I'm gonna give you a second. I'll count to and tell me what you think that number is. If we're going to count by 2, I see Jason's got his fingers out. It's awesome, Jason. You're rocking it. You're rocking it. Use your fingers. It is a lie that to say people who use your fingers aren't math people. I have a master's of mathematics, and I still count on my fingers. Let's bring the fingers back. All right, so let's go. 2, 4. Now, not 6. If you say 6, that's a Martian word for insulting my mother, okay? So that word's not allowed. So 2, 4, 10, 12, 14, 20, 22, 24, 30, 32, 34, 40. Awesome. I see some people, Shannon, Jimmy, Eric, Tasha. Awesome, awesome, awesome. Okay. All right, let's have some fun. What you're looking at now, and here's where it gets fun, you're looking at 2 10 frames. Whoa. 2 10 frames, okay? 10 frames in the Martian world. So here's what I'm going to do. I put some dots in. I put some red dots in. I put some yellow dots in. Write in the chat, come up with, or just in your head, what are 3 questions you could make out of this picture? What are 3 questions you could make out of this picture? Awesome. I see 4 plus 5, 2 plus 2 plus 3 plus 2. Excellent. Excellent. Woo, Ryan with the integers. All right. Someone has gone to middle school already in this grade 1 class. That is awesome. That is awesome. I love the red. Yes, absolutely. I'm trying to also show you, just as an aside, what you could do with those humanoids back on planet Earth, some of the tools and some of the interesting things. So what we can do now is, if you think about this, is what's probably easy. It's a lot easier to add these if we actually move them. And of course, if you've ever taught in grade 1, you know that if you tell the kids, here's 4, and then you move this thing over here, they probably have to recount them. Okay, that's called trusting the count. They haven't developed that yet. I'm assuming you all have developed trusting the count. So if I move this over here, I think we would agree that doesn't change the number of things I have. And so now you can see that this is a full 10 frame, and that's 3 more. So I could see that I have 13. It's a little easier to see that if I fill the frame, if we call it, okay? A great tool for elementary kids when they're looking at how to add to 10 and make 10s, okay? All right. What about this one? What about this one? How many dots are there? What are you doing in your head to figure out how many dots? Try not to count by ones. Try not to count by ones. Be awesome. We should have some ambient sound. Do 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 do. All right, I see a lot of people typing 31. It's weird on a webcam. I don't know the speed I'm going. So if I go too fast, just type in the chat, slow down, cut the coffee. Okay, I put Red Bull in my coffee, so it's like a double whammy. All right. Okay, some people see 31, maybe 41. I agree that the easiest thing to count by, as we know in early elementary, is tens. Like tens, because they mimic the same numbering system. Counting by tens is exactly the same as counting by ones, which is the exact same as counting by hundreds, thousands, 10,000s. And Ryan says 4. Awesome, let's take some chances. We're all in grade 1. We're allowed to be wrong. Let's be silly. It's probably easier, though, I think, if I move these. So if I move this over here, oh, integers, Ryan, love it. 0 pairs, buddy, 0 pairs. It's in grade 1, Ryan. We're not all advanced, so we're gonna treat these all as positive 1, but I love the way you're thinking. I love the way you're thinking. So if I move this around, maybe that one goes there, and then I can move this one up here, and then this one up here, and then hopefully it's easy to see. Count with me, 10, 20, 30, 1. Yes, awesome, 31. So obviously now we're just looking at some subitizing, numbering recognition. Then I fill a frame, that's a 10, okay? Awesome. All right, abstract time, baby. Try one of those questions. Now, I think that you probably, hopefully have a piece of paper nearby. If not, you're gonna grab one or do it on your fingers, do it on your hands. Try one of those questions. I'm gonna go through them. I'm gonna give you right now a task called parallel tasking made by Dr. Miriam Small, an amazing activity. You give 3 questions, or 4 in this case, of different difficulty, and let students self-differentiate. So either, can you add 3 plus 5? Can you go 11 plus 5 plus 4? Can you go 33 plus 24? Or can you do the challenge question, which is this? What 3 distinct numbers, meaning they're all different, add to 40? What 3 distinct numbers, which are different, add to 40? I will give you 2 minutes to try one of these amazing grade 1 math problems. Oh my gosh, Jimmy's right on this. I love it. All right, for those who are cheating, and I say cheating in that you're adding 33 and 24 and then just reverting it to base 6, be very, very careful. 33 is not those humanoids 33. It's a Martian 33. 24 is not a humanoid 24. It's a Martian 24. So, ooh, I love it. I love it. We got some debate happening on what 33 plus 24 is. So I'm going to give you about 2 more minutes, and then I'm actually going to ask someone to unmute their mic on each question. And we're going to hear from the audience, if you will, on how they would have done these. Water break. Okay, we're going to try something crazy. I hope we all have social norms. So if someone's talking, don't unmute. Can someone unmute and tell me how you would add 3 plus 5? I don't care about the answer. Obviously, you're going to tell us during your answer, but I want to more know, how did you get there? How did you get what 3 plus 5 was? Someone want to do that?
I broke it down into 3 plus 3 plus 2.
Awesome. Cody, why 3 plus 3 plus 2?
Because the 5, thinking of that base 10 or base 6, I guess, is the 3 plus 2 is 5. So it made it easier to make that group of 10.
Excellent. Look what you did. You took 3 from the 5, moved it over to the other 3. As we know, boys and girls in Martian world, 3 plus 3 is 10. And then 10 plus 2 is 12. Awesome. Awesome. Good job. All right. How about any goers on the 11 plus 5 plus 4? Don't make me just call on someone. I will cold call someone.
Hey, Jason here.
Yeah, Jason, go ahead.
Yeah, so I think if you take the 1 away from that 11, now you've got 10. Put the 1 with the 5, and you've got another 10. And add the 4, you've got 24.
Woo! Yeah, my man Jason. Yes. 5 is 1 away from 10, and 11 is 1 more than 10. So it totally makes sense just to move 1 over. Absolutely. Absolutely. So 10 plus 4 is easy now to see it's 24. Excellent. All right, ladies and gentlemen, 33 plus 24. Someone want to take a shot at 33?
Oh, I got this one.
All right, Ryan, go ahead.
So if you rewrite it as 34 plus 24 vertically, you can do your 3 plus 4 is 11, but we don't want to use that 10 down below. So you're going to carry the 1 back up top. So then you have a 1 plus 3 plus 2, which equals 10, but we're in the tens column already, so it's 100. So then you have 101. Okay,
mute the recording for a second, because that's bullshit that you stack those. That is amazing, Ryan. I have done this question to I now 500 people. Never has anyone stacked it. Ryan, I owe you a high five. Okay, that is awesome. The reason that the point is no one stacks this except for you. You've ruined my thunder after, but that's great. You were able to stack it. That is amazing. That's awesome. So if you notice, he went through, he added the 1s, he made some 10s. That's wicked. That's wicked. What I think, does anyone do it differently? Did anyone do it I don't want to say traditional, because that downplays what he did. That was awesome. Did anyone do it differently, like maybe similar to these other strategies, removing numbers? Please, I do not want to downplay, Ryan, what you did. That was awesome. Did anyone do it differently?
I did.
Yeah, go ahead.
So this is Dean here.
Dean?
I broke my 33. I did it like tally bars. 3 10s and 3 1s. And my 24s, 2 10s and 4 1s. Just tally it up, right? So now And I had my 10s on the tally bar, so I had, well, first I guess go to the ones. 4 plus 3 is 7.
Whoa! No, there's no 7. Whoa, there's no 7. There's no 7.
Oh, in my head it's 7, but no, it's 10 and 1. So take away the 6 and you're left with a 1. Carry that 6 over and you have your 3 tally bars plus your 2 tally bars plus 1 more tally bar is another 10.
I love it, Dean. I love it. All right, I'm just giving you a hard time. I'm giving you a hard time. Yes. So
I think I just heard Dean insult your mother in Martian.
Exactly. 6 is insulting my mother. 7 is my brother, and you don't want to know what 8 means. Okay. But yes, I love what he did here. So, and I think I captured it visually here, is instead of the 4, he thought of it as 3 plus 1, because as we see, a 3 and a 3 is not a 6. That's what a humanoid would say, weird people. But us and Martians would say that's a 10. So this is a 10 now. So I'm going to get rid of these 3 3s, and I can put a 10 in, okay? Or 2 3s, sorry. So now I have 30 plus 20, which is 50. 50 is 10 away from 100. Now, whoa, what does that mean? Well, of course that would mean, because if I showed you all my fingers, and I now let each of these represent 10s, I would have 10, 20, 30, 40, 50, 100. Because what does 100 mean? 100 means a full set of 10s. Just like those humanoids. Wait a second, I got these new fingers coming. Boop, boop. Okay, so a humanoid would say if these were 10s, this is 100 because it's a full set of 10s. Us Martians would also call this 100. And so you have 100, so 30, 20, 100, and then the 1 left over, so that would be 101. Okay? Michelle, the point I'm driving home is elementary math is anything but elementary, right? And we want to make sure that kids really understand the concepts that's going down. And unless, and I really would, like, no one has ever stacked it. And that's my point, is that when we go to these questions that we don't really have an understanding of, algorithmic math is usually our last tool we go to. However, in most elementary classes, it's the first tool we show kids, which is really contrary to our thought process. Now, don't get me wrong, stacking is great. Again, I want to give kudos to Ryan, okay? But what I want to make sure is that stacking relies on very algorithmic and abstract thinking. But if we think of a visual sense, these kind of new ideas come out, okay? All right. I'm going to skip the last one just because we're going a little slower. So here we go, boys and girls. I'm being vulnerable. I've never done this. I hope this works. But if you have a tablet, and you can do this, or if you just want to write this down. So if you go to your tablet, if you have something that you can write on the screen, I made a Jamboard for you. I don't know if you've ever played with Jamboard, but if you click bit.ly/jam514, what it does is it takes you now to a virtual space, okay? So anything I type on my Jamboard, you will see instantly. However, you obviously want your own Jamboard. So what you do is these 3 little dots up on the corner and click make a copy. As soon as you do that, you have now taken my digital stuff and now it's yours to write on, okay? So make a copy. Chris will help you there in chat, or Chris, give me a thumbs up if someone's having some problems. And then what I want you to do is go to the next slide. And now with your marker, you actually should be able to write in what you think. If you thought 1 times 1 is 1, you could write, or 1 times 1 is 2, you could write 2 in, okay? You don't like that? Take the eraser and erase it. What's beautiful about this as an aside is all you Martians at home just saw me write that in your Jamboard if you did not make a copy. So if kids who needed to follow along could follow along with my Jamboard. Kids who wanted to go ahead, make a copy, they do their own Jamboard. All right, worst case scenario, if you do not have tech, just write out on a piece of paper this lovely 5x5 multiplication. And boys and girls, we are in grade 4. Do you know your Martian times tables?
Hey,
Try it.
tell us that bit.ly link again.
Yeah, absolutely. It's bit.ly/jam, capital Jam, 514 for the date. Okay? We are still working in Martian. Still working in Martian. Okay? I will give you 2 minutes to do your 5 times 5 multiplication tables. I'll just talk because it's boring if I don't. For those who are struggling, remember, multiplication is really just a form of repeated addition. If you need to go back and make a 10 frame, all the power to you. You need to count on your fingers? Go ahead. It's Thursday morning. Go crazy. Yeah, Chris typed in the wrong link. It's 514, not 414. He's trying to sabotage my session. Jason, I'm intrigued why you said 2 times 2 is 12. Are you on a phone, Jason? Okay, I just love because when you're typing, I can see your finger like goes. That's awesome. I'll watch the chat when you have either A, given up or have done. If you look at the bottom of your bar, you should be able to have reactions. Give me a thumbs up or give me any sort of reaction. And when I see, I'm going to be the worst differentiator on the planet because when the majority of people do it, I will go ahead. But we all know I should really wait for everyone. Oh, I love the fingers. I love people counting on the fingers. It's beautiful. Okay, I see Addie's done. Thank you, Addie. Addie, are you in Red Deer? Is that what that RD means?
Yes, I am.
Oh, way to represent Red Deer. Sorry, I didn't say where I'm from Red Deer too. Is it?
I'm with Red Deer Public.
Oh, awesome, awesome. I'm with the other side.
Yeah, I know.
Okay, we got another one finished. Thanks, Ryan. Ooh, nice, Derek. Way to represent. I will just talk here in a couple slides. What we will do is we're going to do, so if you want to make sure you know how to do this already, is get ready to unmute yourself because in about 2 slides, Chris is going to randomly put you in breakout rooms just to kind of debrief this Martian experience and then pull us all back for some more math. So it'll be a 5-minute breakout really quick just to talk about it and then come back large group. So if you haven't figured out already, you might want to know how to unmute just so you can talk. Yeah, and if you have no cam or no mic, just chat when you get in that breakout room. Or just go take a coffee break. For those just joining us, okay, I'm going to go ahead in about 60 seconds. So if you haven't done, no worries, no worries. You can play around with this. I just wanted to show, hopefully, how hard multiplication is if you're really not even understanding addition, right? But we sometimes shoot through it all. And I will say this while we're going to go ahead, is when you see it up ahead, junior high and middle school people, this is amazing. This is amazing. This is stuff that if you really want to start teaching division with remainders, what we're really doing is what's called modular arithmetic. So we're changing the base to base 6 and doing it. Yeah. Ooh, Katie's cheating. She's using humanoid math for us Martians. I'm just kidding. Brilliant, brilliant. Okay, so hopefully you went through. Usually the ones are pretty easy. And so we know 1 times 1 is 1, 1 times 2 is 2, 3, 4, and 5. And of course, you'll see some symmetry in there. So you'll see 2, 3, 4, 5. Okay? Awesome. All right, someone want to unmute themselves and tell me the row of 2s. What's 2 times 2, 2 times 3, 2 times 4, 2 times 5? Someone want to unmute themselves and just say the row of 2, starting with 2.
I would say, this is Jimmy.
Yeah, Jimmy, go ahead, buddy.
I would say 2.
Yeah.
The second one, 2, 4, 10,
Yeah.
12, 14.
Awesome. Awesome. We're really just counting by 2s, aren't we? Hey, it's pretty easy. 3s. Who wants to do 3s?
Jason here.
Yeah, go ahead, Jason.
3, 10, 13, 20, 23.
Wicked. 4s. 4s. We're getting a little more difficult, ladies and gentlemen. Who's got the 4s?
I've got 4, 12, 20, 24, and 32.
Nice. Nice. And 5s. Right? Counting by 5s is pretty easy, shouldn't it be? Or is it? Anyone got the 5s?
Hey, Dave, Eric here.
Yeah, Eric, go ahead.
We got 14, 23, 32, 41.
Awesome, Eric. Awesome. Awesome. Okay, so there you go. So I have the digital form there. What I want you to do, though, is there's some interesting properties here. Now, and I'm for earlier or now later elementary teachers, if you have this, there's some beautiful patterns in the humanoid 10 by 10 multiplication table. Some beautiful patterns. Here's just the Martian 5 by 5. Does someone want to write in chat any observations they made? I love it already, Jason, and I'll just highlight what Jason wrote. The 3s are like the 5s. Well, that makes sense, because in humanoid world, 5 is a half of 10. In Martian world, 3 is a half of 10. That actually should hurt. 3 out of 10 is a half. Yeah, that's happening. That's legit, okay? 3 out of 10 is 1/2, ladies and gentlemen, on Martian planet. And if you were like, what just happened? Now we're starting to understand why maybe middle school kids might be struggling with some reduction in fractions, when really it might be the number theory that's probably the barrier. I'm glad we're not doing this on a Monday. Okay, so I saw that 3s. Does anyone see 5? Jimmy, my man, Jimmy. 5s. I don't know if you guys know this. Again, I'll try to do this with my hands. Humanoids know this silly 9 trick, right? 9 times 2 is 18, because I have a 1 and 8. 9 times 4 is 36. I am a K-12 math lead, and when I go to schools and I see this, I usually ask the kids, why does that work? And usually, here's their response. Crickets, okay? So what we need to realize is, why does that work? Because the 5s are working now. Look at this. So 5 times 2. 5 times 2 is 14, 1 and 4. Oh my gosh. 5 times 3 is 23. Why is that working? Now, it should make sense it's working, because adding a 5 is really 1 away from 10. So you're adding a 10 and subtracting 1. So adding 5 is the same as adding 10 and subtracting 1. So adding 1 to the 10's digit and subtracting 1 from the 1's digit. Just like those humanoids on planet Earth, when they add 9, don't know if you ever thought of this, but adding 9 is tricky. But adding 10 and subtracting 1 is a lot easier. Someone wrote it up way better, and I love it. Number flexibility. Number flexibility. All right, check this out, ladies and gentlemen. There's your perfect squares. Square root of 13, 3. Square root of 24, 4. And if you're like, what the hell is happening right now? Now we're starting to understand why the grade 8's like, I don't know what the square root of 36 is. Who gives a shit, right? It's because I think sometimes it's this multiplication that we have so much we're building stuff on top of things that are kind of shady, and we keep, and it gets a little more confusing. Joe Bowler said it the best, is that higher math isn't more difficult. What's happening is we just have some problems in the past that we're building on, and those might be coming to the forefront. So anyways, those are your perfect squares in Martian world. Have fun with that, hey? So you can make a 41, ladies and gentlemen, squares arranged in a 5x5 pattern in Martian world. So a 5x5 would create 41. Holy gosh. Oh, that's lots of fun. That's a double-decker bus of joy right there, hey? Okay, so now we are about grade 8, grade 9. Now you middle school teachers and high school teachers, throw this at your kids. I would go a little faster, and then let's have some fun with this. What fraction, decimal, and percent is shaded? You can do one of those. You can do all three. I do not care. So here's a fraction. What fraction, decimal, and percent? What fraction, decimal, and percent? And if you really want to go crazy, 1/3 plus 1/4. What is 1/3 plus 1/4 in Martian world? Okay, I'll give you about 2 minutes to do that. 1/3 plus 1/4. Have fun, be wrong, take a chance. It's Thursday morning. Let's try it. So Ryan, I just got to warn you. I think you may be rewriting the fractions in humanoid world and then trying to convert it into Martian world. Okay. What I love, and just because of lack of, I was hoping to get all through this by 10:20. It is 10:40, ladies and gentlemen. So my timing on the line sucks. Okay. So I'm going to try to go through this a little faster. And I love that when we get to the first one, if you were like me when I first saw this, you're like, nah, I have no idea, and let's work this out. But believe it or not, percents and decimals and fractions kind of work the same no matter the base. This is a half, this first one. Why is it a half? Because it's irrelevant what base we're working in. 1/2 literally means 1 out of 2, 2 equal parts. So I'm going to just do the fractions first. So this is a 1/2. That should be easy. What about this one then? If you looked at this, what fraction would be there? Write it in the chat. So 1/2 really means 1 out of 2. Yeah, awesome, Jimmy and Ryan. Excellent. That just means 2 out of 3, okay? Now, again, if you looked at those and you're like, nah, I don't know what to do, we're starting to understand why kids, again, might take these little ideas that we say, how do you not get it's a half? And it might be a little struggling for them, okay? Awesome. What decimal is this? Now, before you say 0.5, let's remember what we know about these things. This means that if I take this decimal on this side and I add it to the same amount, I think we'd agree the same decimal is shaded, that is not shaded, it has to add to 1. So the question I'm asking is, what decimal, when added to itself, gives you 1 in Martian world? Excellent, 0.3, baby. All right, this is 0.3. And again, if you're like, this is hurting my head, please, please, please. Now we can be a little understanding, right, with these kids. Okay, 0.3. Why? Because 0.3 plus 0.3, 3 plus 3 is 10. Move the decimal over. This would be 1.0. Good. All right. This one now, okay, I'm going to say this in some English here. How would we think about this decimal? Well, we could think of it like this. I know that if I take the decimal and I add it to half the decimal, which would be this white shaded, I should get 1. So that's another way of thinking about this. What decimal, when added to half of itself, gives you 1? Okay? It's really hard. I know it's hard to see with my mouse. I'm really verbally talking visualization. It's the worst way to do it. I'm sorry. But yes, Dean and them got it. 0.4. So this is 0.4. Half of 0.4 would be 0.2. And 0.4 plus 0.2 would give me 1.0. Excellent. Excellent. Okay? We also could think of what number times 3 is 1. Excellent, Ryan. Excellent. I love it. I love it. All right. Does anyone want to try the 1/3 plus 1/4? Unmute yourself. You talk. I'll try to write as you talk. And let's see if we can get this. Does someone want to come up with what is 1/3 plus 1/4? Okay, Jimmy, why 11 over 20?
What I did was I made them a common denominator of 12, but 12 is 20 in Martian world. So
Yes.
and I put the numerator as 7. 7 is actually 10 plus 1 in Martian. So it's 11 over 20.
Awesome. Okay, so Jimmy's going between humanoid and Martian world. What I love about this and why I love doing this activity with people is that, do you see how much you rely on your old previous knowledge? Grade 7 and 9 kids don't have that. They don't have another language to rely on. We are the first time showing these things to kids. When kids see high school rational equations, you're like, oh, it's just like fractions. Some of those kids didn't get fractions. So now we're building stuff on things that is already shoddy, right? I can tell you, Jimmy's got humanoid math. It was very evident right now. And so that was awesome. Good job, Jimmy. You converted it to kind of humanoid, went back to Martians. I love and yeah, I see it as a mixed. Okay. I won't go over this because we're out of time, but I'm saying right now, high school, because I said I would have some all. Algebra changes, ladies and gentlemen. Algebra changes. X is not the same X that we'd have on humanoid world. 25% on Mars is not the same as 25% on Earth. Because 25% means 25 out of 100. But the 100 a humanoid thinks of, when you think of 100 as a human, that's drastically different than what a Martian thinks of 100. Okay? So again, these things that we're taking for granted all the time, we are numerate learners. We have multiple ways of manipulating things. Let's make sure kids know those things. And 3/2 times 4, not the same as it is on planet Earth. Definitely not the same as it is on planet Earth. Okay? So I'm going to skip this because I just think 5 minutes, sorry about the breakouts. Yeah, so I just kind of went through some K to 9 math with you in a whole different set, hopefully to make you a little uncomfortable, push you a bit, and just show you just kind of how difficult these things are, okay? Yeah, PowerPoint is with us. Chris will throw that in the chat right away, okay? So the next thing is, this is kind of the method. I don't know if any of you were in my Essential Ideas a couple weeks ago, but the thing I hit home for all grades is we need to focus more on the representational. We need to focus more on the visualization, okay? Sometimes we do concrete, and then we jump right to abstract. And we wonder why kids kind of miss us. Well, we know from brain research many, many, many times, we have to have math in our hands. Then we have to visualize math, and then it goes into abstract. The speed at which people transcend through those is all different. I agree. But so what we can't assume is that everyone just needs one concrete task, one visualization task, and one representation task. Because I know that if I went into your homes right now, some of you would have done the multiplication tables with dots. Some of you doing the multiplications like Jason was doing with his hands. And some of you, like that crazy guy, was stacking it, okay? I still can't believe you stacked it. That is insane. I'm going to have trouble sleeping tonight because that hurts my head. But anyways, I think that you see how, imagine if I said to you all have to stack it. Ryan would have got it. I think it was Ryan. And the rest of you are like, what is this crap? While the other hand, if I said, well, Jason's using his finger, so you have to too, Ryan would have became bored. So we have to make sure that we know that kids transcend through these all at different speeds and paces. And that's the beauty about being human. And saying that, we are back on planet Earth, ladies and gentlemen, okay? So take off your spacesuit, breathe some air. Woo, that was exciting. All right, I want to show you now a simple counting activity that grade 1s can do all the way to grade 12s. And the questions you ask will be different based on the levels you have, okay? So this is the recommend sequence. Oh my gosh, ladies and gentlemen, we are about to have some fun, okay? Here's how this works. I'm going to just talk about it and go. If you have your Jamboard, if you got your Jamboard, what I'm going to invite you to do is go to slide 3, okay? If you don't have a Jamboard, just take a piece of paper, make a quick line, and draw the numbers 1 to 25 on it. 20, you obviously could go to infinity. We're going to be here all day if you do that, but 25 gets you kind of an idea. I want to show you this beautiful artistic sequence that was created by a mathematician, Recommend, that just asked this simple question. What happens if I draw a sequence like this? So we're going to start at 0, okay? And so you can see there's a 0. We're going to start now as a jump of 1. Here's how we always do. We only deal with positive numbers, and we only deal with numbers. Numbers are only allowed to ever be touched once. Okay, so I'm gonna look right now at a jump of 1, okay? So I can't go back 1, always try to go back. I think we'd agree at 0, I can't go back 1 because there's no numbers to the left of 0. Yes, there are negative numbers in this sequence, no negatives are allowed. So the only thing I can do is go forward 1. So I'm gonna do that. I'm gonna make a little boop. Now the next sequence is I did 1, let's try 2. So can I go back 2? I'm at 1. Can I go back 2? No, that deals with negatives. So what am I going to do? I'm going to go forward 2. Now this time we're going to draw the sequence underneath, the little spiral underneath. It's like a half circle. Now we're at 3. Can I go back 3? Well, 3 minus 3 is 0. That's great. But do you see how 0's already been checked? Can't do it. So again, I'm going to go forward. What's 3 plus 3, everyone? On humanoid world is 6. So I'm going to go from 3. And I'm going to make a bigger circle to 6. Okay. Now we're going to look at the number 4, step 4. Okay, always try to go back. What is 6 minus 4? 2. Oh my gosh, we haven't got to 2 yet. So now I'm going to spiral back to 2. So far, so good? Now we're looking at steps of 5. Well, I can't go backwards 5 from 2. That gets me negative. So I can go forward. 2 plus 5 is 7. Come around. Okay. Now we're at 6. 7 minus 6 is 1. 1's already been touched. So what's 7 plus 6? 13. Woohoo! So I go all the way to 13. Hopefully I'm going okay. Next is 7. What's 7 minus 13? 13 minus 7, my apologies. 13 minus 7 is 6, right? Okay, I can't go back to 6, so I'm gonna go up 7 more. That takes me to 20. We good? Yes, okay. Now we're at 8. Ooh, 20 minus 8 is 12. Look at that, I can go back to 12. Hopefully I'm going back. So you always check to go back, then you go forward. Oops, I kind of missed 12 there. Okay, now 9. 12 minus 9 is 3. 3's already been checked off, so I'll go forward 9, and you get 21. 10 more now. I can go back 10. 21 minus 10 is 11. 11 hasn't been touched. So far, so good. Erase these numbers at the top here. Okay, so that's 10. Now I'm at a jump of 11. So I can't go back 11 because 11 minus 11 brings me to 0. 0's already been touched. So I'm going to go forward. 11 plus 11 is 22. Okay, now let's go. That was 11. Let's go 12 jumps. 22 minus 12 is 10. Has 10 been touched yet? No. So we go back to 10. And you're going to start now. We go right. Then we go 13. What's beautiful about this, if you continue doing this, because I am just looking at some time, I apologize. We're going to do this a lot. This is what you get. You get this beautiful spiral. Now, I'm being sincere. When you do this on graph paper, and if you have like things, you get this amazing thing. But there's so much more to this simple sequence that a lot of people don't realize is this. And I don't think you can show it, but if you click on listen, what someone has done is taken this sequence of numbers that we've kind of drawn and made it into an octave, and it creates this beautiful tune. I know you've probably heard music of pi, the digits of pi. Here's something that literally a mathematician just sat around and said, what if we just created a sequence like this? What would happen? And so you can actually, if you hit play, you can actually listen to it. I don't think you can you guys hear that? No, okay. Well, you can do it on your own time, okay? That's a Friday night date night right there, okay? Bottle of wine, put some ambient music, and play the recommend sequence. Oh my gosh, the love is in the air, okay? The next thing is you can explore the sequence. So if you click on this, this is actually a number file video who goes in and really talks about it. But here's the other thing. You high school teachers, ask kids to code this. The people who, and literally, you can code this in Scratch. You can code this in Python. Anyone who's known any kind of coding has done it, okay? But the question, though, I would ask, and so this is a beautiful coloring on this side right here. What someone has done is made the recommend sequence and then colored it in, okay? Here are some beautiful things that early ages, grade 1 and 2, you're just counting. You're just learning simple addition, subtraction, and going through it. Higher levels, here's the question. Will all numbers be hit in this sequence? Will I hit every single number on the number line by doing this sequence? Fun fact, never been proven. $1 million online. $1 million. If you can prove it, that every single number hits, you get $1 million. Right now, they have a computer that's done it up to, I think, 53,000 or 51 with 53 zeros after it, whatever number that is. And every number they've mathematically, or the computer's shown that every number up to that point is hit. We don't know what happens after that. Computers is just too much processing power. And so, but here's an awesome sequence that I think creates some mystery and joy about, and this beautiful, beautiful picture, okay? Beautiful, beautiful picture. Awesome. The next thing is with this is 2. So now, elementary, middle school, I would kind of start with that. Now from middle school up to high school, try the trapped knight. Oh my gosh. The trapped knight is a beautiful, beautiful picture. So here's how the trapped knight works. Is imagine this. We take a spiral. I'm going to put the numbers in, sorry. Show numbers. And just so you can see, I'm just going to up this a little bit. So is imagine this. You take the numbers. I don't know if you can see. It's 1, 2, 3, 4, 5, and it's spiraled out. Okay? Here's the task. A knight, just like a knight in chess, has to move 2 up, 1 over. 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 But this knight always goes to the smallest number it's never been to before. So from 1, you can see it could go 1, 2 over and hit 12. Okay, 12 is good. But it could go 1, 2, and then down and hit 10. 10 is smaller than 12. That's the smallest number it gets to. Then from there, it jumps to 3. And what I'll do is I'll show you the animation again. This is actually how the knight moves. Pretty interesting. And if you zoom out, which, sorry, I'll zoom out now, it creates this beautiful pattern again. It kind of looks like this spiral. The big question, though, is, will every number be touched? Now, at this point, you can see that every number has been touched. There isn't a dot that's not been hit yet. But will it always continue to do this? And this beautiful, beautiful thing, it's called the trapped knight, is it actually creates this spiral pattern around the number lines. What I would do, I wouldn't maybe do this in elementary, but your middle school and high school people, this could be a fun activity that maybe you start a class with, give it to the kids over the weekend. Can they draw it? Can they color it? There's a whole bunch of animated versions. It is awesome. It is awesome. Creates some real good joy, okay? All right, we got 3 minutes left. I am sorry, you're not gonna have a chance to play with any of these. You're just gonna have to listen to me for 7 minutes. Enjoy, okay? Think of this as upcoming date night activities for tomorrow, okay? You and the spouse, bottles of wine, play that recommend sequence in the background. Joy is in the air. Okay, so the first thing is square numbers. I know that we see a lot of this, but do kids actually know that a square number truly means it can be made as a square? I have to talk to lots of kids who know that square roots of 36 is 6, but can't explain to me, can you visually show that? And so we start with square numbers. That's easy, okay? But did you know that there were triangle numbers? That numbers actually form triangles? That there's this cool sequence of triangular numbers? Okay? And high school peeps, you ready to have your mind blown? Hexagonal sums, baby. Hexagonal sums. If I take a hexagon and connect it to dots, and each time extending the hexagon one more and putting each previous hexagon inside the previous one, you enter what's called hexadecimal coding. These are sums, though, of the numbers as you go up. My question to you, and what I was going to give you if I had time and I learned how to talk quicker, I guess, is looking at some of these, what's the pattern? What is it going up by? Don't know if you knew this, but squares go up by an increasing amount every time. 1 to 4 is an addition of 3. 4 to 9 is addition of 5. So went 3 to 5. 9 plus 6 is an addition of 7. It's adding consecutive odd numbers. Don't know if you knew that. Okay, so if you add consecutively odd numbers, you get square numbers. What's the pattern for triangular numbers? What's the pattern for hexagonal sums? Fun fact, this is a quadratic here. So grade math 20-1 teachers, if you're here, give this to your class and say, I wouldn't say it's quadratic. I would say, is it linear? Is it sinusoidal? For 30-1, you could ask that question. What's the pattern? What's the formula? How do I get the nth hexagonal sum? What's happening here? Oh my God, the joy. It's gonna be great, okay? Last one is a Diffie Square. I'll give this to you. I gave this in the K-2 world last week or a couple weeks ago. How this works is Diffie Squares was created by a gentleman, Dan Finkel, okay? And I'm just gonna zip to it right now. How Diffie squares work is this, is if you start with some kind of numbers, and it doesn't matter, I'm gonna go nice numbers, but then I'm gonna talk about high school people, what you could do. I'm gonna say maybe a 2 goes here, a 3 goes there, 3 and a 4, I don't know. Just random numbers, here's the beauty of it. And what we're gonna do is I'm on the midpoint of every single square, here, maybe I'll use a different color so you can see, is I'm going to put the positive difference. So the difference between 2 and 3 is 1. So I'll put 1 there. The positive difference between 3 and 4 is also 1. Oh, this won't be interesting. That's okay. The positive difference, okay, yeah, I'm going to change the, anyway, well, we're going to do it anyways. The difference between 3 and 4 is also 1. And the positive difference between 2 and 3 is 1. Interesting. If I connect these dots now, awesome geometry thing, you get another square. All right, let's do it again. The positive difference between 1 and 1 would be 0. The positive difference between this 1 and 1 is also 0. That's why I said this really wasn't interesting. Poor Dave. Should have picked some more interesting numbers. But this is also 0. 1 and 1 is also 0. And now we have a square which is 0. And unfortunately, 0 minus 0 will just continue on to zeros, okay? The question, though, I'd ask is that always the case? Will I always get zeros? And before you high school people say, well, that's interesting. How does this engage kids? What if the vertices were root 8 to root 2, root 4, or root 6? Things that with radicals. What if in 30-1, one of the numbers was 3 pi, 2 pi, pi over 2, and pi over 4? Does the Diffie square still get to zeros if we do irrational numbers? Fun fact, it sure does, right? What if it was x, 3x, 4x, and 2x? Oh my God, subtracting equivalent expressions in the form of a Diffie square, will you still get to 0? These are some cool things that we can really extend to all levels. That grade 1 kids are playing it within single numbers, and high school kids are doing radicals, fractions. Oh my gosh, the stuff that we can do, okay? Yeah, Ramsey numbers, that's going to take a whole lot longer. If you just want to go Ramsey numbers, that's a whole lot of fun, okay? I'll leave that as a homework assignment. Maybe up in an upcoming webinar, we'll talk more about that. But that has to do with people in a room. If you knew people and if you didn't know people, can you create groups of people? Oh my gosh, a whole bunch of fun. It's 10:58. I always promise to end early. So if you want, if you click on that link here, you will get I did not link it. If you click on the link, you got to do one more and click on class activities. I'm sorry, I will up that link right now. Just hang on. Don't click on it yet. Don't click. Don't click. Boom. All right, click. All right, so if you click on it now, it'll take you right to the page. This is a math site that I developed for my tire division. Feel free to take anything you want from it, change it however you want. You've now been given full permission to make it all yours, whatever you want. A whole bunch of stuff there. Please feel free to do it. There's my email. There's my Twitter handle to go out. Chris has it up there as well. And yeah, so thank you for spending Thursday morning with me. Cheers, have a happy coffee, and enjoy the very long weekend and wash your hands. All right, off to Chris.
Now, I would dare anyone to argue that that wasn't a great way to spend an hour on Thursday morning. Dave, thank you for your passion. You are so exciting just to listen to and to participate in, and you get us excited about math. So we really appreciate you being here. The way that you teach and the way that you just excite us about ways that we can challenge our students is awesome. So thank you so much for being willing to serve your colleagues in this manner. It's such a gift to us. So that's our session for today. I'm going to stop the recording, and if you have questions or thoughts or things that you'd like to chat with Dave or I about, you're more than welcome to do that. Once the recording is stopped, if you want to open up your mics, you're welcome to do that piece as well. So thank you again, everyone, for joining us. Always an awesome session. We hope that you have a fabulous long weekend if we don't see you before that, and take care.